answer is, how can you have a mutation and not have any effect on the organism? So we have this random strand of DNA that I sort of plucked out of thin air in my own head. I think I have a mistake. Okay, so what's the first step in making a protein from a segment of DNA? Unzip it. I wish I had a hoodie on and I could go zzz. Unzip it. So we're going to just move this one down a little bit. And we're only doing, this is just a few of those little triplets. We're not doing a whole section. And I'm going to insert, I'm going to create a copy. What's the copy? mRNA, yep. So GGG pairs to CCC, AAA pairs to what? U. Yes. I'm making those pink. I should make that a darker pink. I lined them up badly again, didn't I? There, we'll do that. And T pairs to what? A. C pairs to G. G's pair to C's. And the C's pair to G's. Okay, so now I can take my mRNA, zoop, and I'm going to move it right out. I'm going to rezip my DNA because we don't need it anymore. Boop. And I'm going to take this mRNA and I'm going to feed it right into a what? Ribosome. I'm going to shove it right through a ribosome, and as it goes into that ribosome, it's going to start creating a chain of proteins out of what? Out of amino acids. So my first codon, remember those 3 base mRNA segments are codons, is CCC. So if I go to my chart and I go C, 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 that gets me proline. And then my mRNA continues to move. And the next chunk is U. What does that get me? Let's see. U. Gets me phenyl alanine. Phenyl alanine. It's fun to say. We're going to go ahead and keep moving my mRNA right through the ribosome. It's kind of getting squished up as I go, but that's okay. I have AGC. What will that get me? AGC gets me serine. Did I screw something up? No. Okay. And then my last one. You got this already, huh? Good. Is a CGG. I somehow have my spacing off a little bit, but hopefully that's forgivable. I have my CGG, and CGG gets me CGG arginine.
I like the lined one.
What?
I like the lined one better.
The lined one better? Really? That's it. Well, that's good. Here's why that's good. I try to make sure I use both because both are used.
It's confusing with so many letters in one spot.
Okay. We can use the square one. I actually think the circular one's much easier to use because you're just tracing out from the middle, and my eyes tend to cross lines. Here's the thing, though. They usually use I have only seen the square one on the air test. So I want to make sure you're familiar with both of them, but, you know, arginine. There we go. Okay, so we would also, and I forgot to put it on there, we would have a stop codon. The stop codon just says, okay, the protein's done, we stop, it's finished. Now I'm going to set this all aside. I'm going to shrink this. And hopefully you wrote this down. And I'm going to bring this over here. I'm going to copy this. I'm going to paste it. Gesundheit. Because I'm going to assume that a mutation occurred in copying this strand of DNA, and we are going to make protein from the mutated DNA. So let's imagine that instead of AAA, our second codon is AAC. So somehow we got a mistaken letter in there, and you notice that this is definitely not what was there. It doesn't match the other half of the strand, but somehow this was not caught. Remember, you're making, what, 120,000 mistakes every few seconds or something, and your body is catching most of them. But this one got through. So let's look at the mRNA that would be generated from this. So I'm going to make my mRNA. There's my backbone, CCC, UU. Oh, instead of UUU, I have UUG. And then I've got A with G, C, and then C, GG. Okay, so I've got my mRNA. I can feed this into a ribosome. I'm going to zip my DNA back up. And at this point, maybe the DNA gets repaired. Maybe it replicates off that, and now we have a permanent change. It's going to get passed on as long as that cell is alive. So if we feed this through a ribosome, let's see what we get. Well, CCC, that's the same, nothing changed. That's proline. What about UUG? What does that get us? So I'm going to start with U, then I'm going to go to U, and then I'm going to go to G. Leucine. That changed the amino acid. I mean, we didn't have any other changes, so we know it's going to go serine, arginine. Do we know if that's going to make some kind of major difference in the organism? We don't know that, but we definitely have a slightly different protein now. If this is a protein that is making your bacterial cell wall, maybe it's not as thick. Maybe, who knows? We don't know what that change is going to mean. And I'll go ahead and finish that polypeptide. I'll finish that. Serine. But this is different. Arginine. That is definitely different. So let's set this aside. I mean, that's how we get one that does have a change. I should highlight that. What if in this strand of DNA, what if we had A, G? So let's say we get a G substituted in there. So we have a substitution error, we have a single base change, we have a G instead of, there had been an A there originally. Let's make the mRNA and see what we get out of that.
Glycine.
Do we?
Mm-hmm.
Are you sure?
Yeah. Glycine.
I hope not.
It's AAG, it's glycine.
Well, except that's going to be UUC. UUC.
Phenyl Alanine.
A, G, C, C, G, G. Now, of course, we know we only changed that one codon. So let's zip our DNA back up. Boop. And maybe at this point the body's error checking mechanism catches on. So here we have what? Phenylalanine. I'm sorry. No, proline.
Phenyl Alanine.
UUC. UUC. Hey!
Phenyl Alanine.
Phenylalanine. That's the same thing we had up here. We changed a base, but because there are multiple codons that code for each of these bases, and we know the rest is going to be serine and arginine.
That's how mutations have an effect.
Well, that's how you can occasionally get a mutation that doesn't have any effect on the organism, because there are actually multiple codons for a lot of these. Now, what would happen if there was a mutation that caused this to be a stop codon? No protein. Yeah, exactly. You would literally not have a protein constructed there. That would be bad. What if halfway down the protein you suddenly had a mutation that caused there to be a stop codon? You'd have a shortened protein, and it might not work correctly. So, in a few, it probably just did, or it's about to, you're going to have a recall quiz that posts. So, until it posts, what I want you to do is pull out the vocab, look at part C's, see if there are any that you can see clear to defining in your own words. I was seeing how many ways I could work C into the sentence. Turn in that worksheet if you're done with it. If you need help with it, I'll float around and help. Turn in your part, or look at your part C's, get those. I'm anticipating your test will be next Wednesday, a week from today. And then look over your part C's and get ready for the recall quiz, and then we'll talk about the plan for the next week.